Okay, so today we're going to talk about Unit 9, Day 3. Yesterday we did some probability. Today we're going to do probability of multiple events. So our learning target, I can determine if the probability of one event affects the probability of another. And I can find the probability of two or more events occurring together. One thing, though, that's important is if you have two different events, say event A and event B, when it's important to distinguish between A and B happening versus A or B happening. So A and B means both of them have to occur in order for this to be true, whereas A or B, just A could happen, or B could happen, or both could happen. So it's two different ideas. First, we need to talk about independent versus dependent events. So when the occurrence of one event affects how a second event occurs, the events are dependent. One depends on the other. Otherwise, if one does not affect the outcome of the other one, then they're independent. So some examples here. Are the outcomes of each dependent or independent? So say I roll a number cube or a die. Then I spin a spinner. Does the result of the cube affect the result of the spinner? So if I roll a 5, does that mean one of these numbers are more likely to happen than the other, or does it change? And in this case, no. A number cube and a spinner, they don't matter. They don't affect each other at all. So this one, they are independent. I take a flashcard from a pile of cards. Then I take a second one without putting the first one back. Okay, so say there's 10 cards on there, and 5 of them are red and 5 of them are blue. I pull a red one out, and I don't put it back. When I go to take the second card, there's only 9 cards left. And if I took one of the red ones, now there's only 4 left. So there were 5 out of 10, now there's 4 out of 9. Suddenly the probability changed. So when I do not replace it without putting the first one back, that does affect the second event. The first event was drawing a card, the second one was drawing a card, but the card's missing, so everything changed. So those are dependent events. But what if I take a flashcard from the pile, then I take a second one after I replace the first one randomly? So I took a flashcard out, I looked at it, and then I put it back in randomly, sort them. Now it's the same number of cards, same number of everything, so now they're independent events. The second result does not depend on the first result, so this one would be independent. Okay, and we'll talk about some, especially tomorrow, we'll do some different kinds of this, whether they're independent or dependent. Like we could look at grades and say, it's the probability of getting an A, is that independent of your gender? So maybe being a female makes you more or less likely, or being a male makes you more or less likely. Now, if it's the same either way, then they're independent events. So there are ways of doing that, and that is we have to do some experimental probability with that, where you have to collect data, versus this is theoretical. I don't have to count the card. All the cards are in front of me, so it's theoretical. What is the probability of rolling a 3 on a fair die, which is a number cube, and drawing a heart from a 52 card deck? Okay, so first off, if they're independent, then I can use this. The probability of A and B occurring together is the probability of A times the probability of B. Now, does rolling a 3 on the die affect which card I draw out of the deck? No, so they're independent. So since they're independent, I can do this. So the probability of A and B, or in this case, rolling a 3 and getting a heart, I'll put 3 and H in there, is going to be the probability of rolling a 3 times the probability of rolling a heart. The probability of rolling a 3, if there's 6 sides, because it's a fair die, would be a 1 out of 6. And the probability of drawing a heart, there's 4 suits, so it would be a 1 out of 4. So the probability of these occurring together is a 1 in 24 chance, which is 0.042. So if you write as a fraction or as a decimal, there you go. Another example, there are 15 marbles in a bag. 5 are red, 7 are green, and the rest are blue. What's the probability of drawing a blue followed by a green if the first marble was replaced? If it was replaced, that means they're independent of each other. Okay, so we'll do that first. We'll do this. We'll do that and not replace second. So I need to figure out what's the probability of drawing a blue and probability of drawing a green. Well, I'm going to take, I don't know why I wrote like that, B and G I should have put. So we'll say probability of B and G. So over here, that's going to be times. That's why I want to write it. So probability of drawing a blue. Well, there are 15 marbles. So both of these are going to be out of 15 because in both cases there were 15 marbles in the bag to begin with. The green ones, there were 7 green ones. There were 5 red, that means 12. So the rest, 3 were blue. So there were 3 blue ones and there were 7 green ones. So if I multiply those together, that's going to equal 7. I'm sorry. I can do some reducing. In my head I reduced. So 3 and 15 are reduced to 1 and 5. And now multiply. So that'd be 7 out of 75, which is 0.093. Okay. So not real likely, about 9.3% chance of that happening. But then we need to look at what if it was not replaced. So it is important on here to look at the order that it happens. So the probability of drawing a blue, now that's when we were given the bag, there's 15 marbles in the bag, 3 of them are blue. So that's 3 out of 15. So probability of blue. Now, that stayed out, so the next time I'm going to get a green, 7 of the marbles left are still green, but there's only 14 left in the bag, so half of the marbles left are green at that point, whereas before it was 7 out of 15, now it's 7 out of 14. So if I multiply these together, and it's the probability of green, given that it wasn't replaced, so this is a 1 and a 5, so that'd be a 7, well, in fact, I can go 1 and a 2 on this one, so that'd be a 1 out of 10, which is 0.1. So it's actually more likely to happen if the first one wasn't replaced. If we kept the marble out, tried again, we have a higher probability of it happening. So that's dependent, independent. A whole other idea is what's called mutually exclusive. And oftentimes we mix these up. We get these mixed up together. Students will think if something's mutually exclusive, that means it is independent, if, and vice versa. They're not. Okay, that's not the case. And we'll talk about it at the bottom of the page here. But 2 events that cannot happen together are called mutually exclusive events. So for instance, you can't, when you roll a dice, you can't get a 2 and a 3 at the same time. You'd have to roll it a second time to get a 3. So you can't get a 2 and a 3, or you can't go to the pet store and say, I want a dog and a cat, but you only get 1 pet. Now, if it's 2 separate events, sure, you can get a dog and you can get a cat, but you can't do both. You can't draw a card and it's a heart and a diamond at the same time. So those are mutually exclusive, which is kind of a confusing word because mutually means together and exclusive means apart. So together they're apart, but that's besides the fact. Now you could roll a 2 and get an even. So if I roll the dice, it can be 2 and even at the same time. That's okay. Or I could choose a dog and a poodle. If I get 1 pet, it could be a dog and a poodle at the same time. Or I could choose a heart that's also an ace. The ace of hearts is both. So these are not mutually exclusive. These are mutually exclusive. Okay. So if A and B are mutually exclusive events, you can just add the 2 probabilities together. What's the probability of A or B is you just take the probability of A plus the probability of B. But if there's any way that they could be the same, like if I could draw a heart and an ace, I need to look at them being counted twice here. So I have to do, it's the same formula, but now I'm going to subtract anything that's both. Okay? So these are the formulas we're going to be using. We'll get to these on the back. Yeah, but first let's talk about this. It just happened to fit in the notes better here. Independent. Does independent mean mutually exclusive? If 2 events are independent, does that mean they're also mutually exclusive? So let the probability of event A, so say the probability of you getting an A in algebra 2 is 0.25. The probability of you getting a B is 0.35. Are those events mutually exclusive? So can you get an A and a B at the same time? You can't. It's one or the other. So these are, yes, they are mutually exclusive. Now, are they independent? So does getting an A affect the probability of getting a B? So let's say you do get an A in this class. what's the probability you get a B then? 0, right? It just dropped. You can't. If you get an A, you can't get a B. So this occurring makes that 0. Or this occurring, if you get a B, that means you can't get an A. So this one is no. You can't get an A at the same time you get a B. So once you get one, the other one's probability drops to 0. So this is not true. No. Okay. Uh-oh, I just did a double negative there. So mutually exclusive or independent equals mutually exclusive? No. That just reminded me of an Office episode. So the Office fans, you know what I'm talking about. Flip it over. So let's, sometimes we just give you straight up, it's not even a word problem. It's just we say A and B are independent. So that means the probability of A does not affect the probability of B. If that's the case, you can just multiply them together. So probability of A plus B equals a probability of A times a probability of B. So in this case, I would take 1/6 times 2/5. I could do some reducing here, so 1 and 3, so 1 times 1, and that's out of 15, so 0.067. So 0.067 chance of that happening. A and B are mutually exclusive. Okay, so if they are mutually exclusive, that means they can't happen together. So you can literally just take the probability of C plus the probability of D. So the probability of C plus the probability of D. So this would be 1/2 plus 3/8. Be careful on this because you do need common denominators to do this. So if I want them to share the denominator of 8, I got to multiply it by 4. So multiply this by 4, multiply that by 4. So 4/8 is the same thing as 1/2. So that would be a 7/8 chance, 0.875. Okay, so if they're mutually exclusive, just add them together. Okay, so some real applications here. These are just the outcomes. So if I roll 2 dice, these are the sums of what can come out. So if I roll 1 and a 1, the sum is 2. If I roll a 4 and a 3, the sum is 7. So these are all the possible, this is the first, or I should say first dice, second dice, these are all what could happen. So it's 36 things that could happen. Whereas over here are the products. So if I rolled a 4 and a 2, the product's 8. Okay, so I'm going to use this to answer my questions. So say I roll 2 fair dice. Determine if the 2 events are mutually exclusive, then find A or B, the probability of one happening to the other. So first off, are they mutually exclusive? So mutually exclusive means they can't happen together. So the sum is a prime number. The sum is less than 5. So are there any prime numbers, any prime sums less than 5? Well, 2 is prime, 3 is prime, so that could happen. So you could roll a prime number that is less than 5. That means that you could actually get both at the same time, so that's not mutually exclusive. So if they're not mutually exclusive, the formula is the probability of A or B is going to be the probability of A plus the probability of B. But now I need to subtract the probability of A and B, because if it can happen, I just counted it twice. Okay, so for instance, looking up here, so looking at the sums, the sum is less than 5. So that would be all of these right here. So if I add all those up, that's 1, 2, 3, 4, 5, 6. Okay, so 6 out of 36 are less than 5. But how many, the sum is prime. Well, how many numbers are prime up here? So I got 1, 2, 3. If you notice, those 3, I just counted them twice. They were counted in this total and in that total. So they got counted twice, which isn't really fair. So 1, 2, 3, 4 is not prime, 5 is. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So those are the prime numbers I see. So 15 out of 36. But again, some of those were counted twice. Okay, some of those I just counted twice. That's not, it's going to make it look like it's more likely to happen. So I need to subtract all of them that happened twice, and I need to subtract them one time. So both of them would be 1, 2, 3. Okay, so 3 of those. So that means I have 18, so I have 15 plus 6 minus 3 is 18 out of 36. which means it's a 1/2 or 0.5 probability. Okay, so the probability of rolling a prime number or, a prime sum or a sum less than 5, which kind of sounds crazy. Like half of the time you'll get one of those. I would have guessed that ahead of time. Number 4, the numbers are equal. So you roll 2 dice and they're equal, or their sum is odd. Now, can you roll where the sum is odd and they're equal? So is there ever a way that the two numbers are the same and they equal an odd number? Well, any number plus itself is going to be even. So these are mutually exclusive. So mutually exclusive. So when I do the probability of A or B, I can just do the probability of A plus the probability of B, and I'm done. There is no overlap, so I don't have to subtract. I didn't count anything twice. So what's the probability that the numbers are equal? Well, that'd be a 1 and a 1, 2 and a 2, a 3 and a 3. So it's just this column here. So 1, 2, 3, 4, 5, 6. There's only 6 different ways I can get equal numbers. So 6 out of the 36. And then how many numbers are odd? So go through and look at all the odds here. That's right, the sum is odd. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 out of 36. Now when I did that, I looked at those two, none of them overlapped. So I just need to add those two together. 24 out of 36, which is the same thing as 2 out of 3, or 0.667. Number 5, what's the probability of the product? So that's this one over here. The product is greater than 20. So let's look at the products here. We've got those guys right there. That's the first group. And then the product is a multiple of 3. So are any of these multiples of 3? Oh yeah, there's a bunch of them are. So these, it's possible for them to happen together. So this is not mutually exclusive. I'll put M.E. So that means the probability of A plus the probability of B minus the probability of A and B. So what's the probability that the product is greater than 20? Well, there's 1, 2, 3, 4, 5. 5 of these. Why am I getting, wait a second, 1, 2, 3, 4, 5, 6. So 6 out of 36. Now, what's the probability that the product is a multiple of 3? Okay, well, out of all of them, see, these are multiples of 3, because I multiplied by 3 to get them. I also can go this way. So these are multiples of 3. These are multiples of 3. And these are multiples of 3. So all those I put check marks on are multiples of 3, because I did the 3 and the 6 rows and columns. And there are, see, 20 of those. There are 20 of those. So 20 out of 36. Now, how many are both? So I circled them and I checked them. So 1, 2, 3, 4, 5. Ooh, 5 of them were both. So 5 out of 36. That's going to be a 21 out of 36, which is 0.583. Oops, sorry. 21 out of 36, 0.583. Let's see. So number 6, let's say a multiple choice test has 4 choices for each answer, A, B, C, D. Suppose you make a random guess on 3 of the 10 questions. What's the probability that you will answer all 3 of them correctly? So first off, if you just guessed on these 3, the first one you had a 1 in 4 chance, does that affect the next one? So what you guess on the previous one, does that affect the next one? It shouldn't. I mean, if you're randomly guessing, it shouldn't affect it. Now, if you're a person that says, I'm going to put C every time, well, now that's different. But you're randomly guessing. So randomly guessing. So is each guess dependent or independent? They are independent. So now I can so the next one's going to be 1/4, and the next one's going to be 1/4. So that's a 1 in 64 chance you get all 3 of them right. What's the probability that a random guess on one question will yield just one of them will be correct? Okay, so you just want to know if one of them is right. All right. I'm sorry, actually, if on one question. So if you just have one single question you want to guess on, what's the probability you get that one right? It's a 1 in 4 chance of getting that right. Number 7, let's say that, what's the probability that a mother has 3 daughters. So any mom out there, what's the probability they have 3 daughters? Well, the first one being a daughter is a 1 out of 2. Does that affect the next one? Absolutely not. So whether or not you have a child, whatever gender, the next one is not going to be affected. So the second child is a 1 out of 2. The third one's a 1 out of 2. The probability of all of them happening is a 1 in 8. So there's a 1 in 8 chance that your first 3 children will all be daughters. That same mother is expecting with her 4th child. What's the probability the 4th child is also a girl? And a lot of times people would joke and say, well, if you had 3 girls, the next one has to be a boy. It's going to be a higher probability of being a boy. All we're saying is, what's the probability that the 4th child you have is a girl? It's still 1 out of 2 because they're independent. So since each birth gender, so each birth is independent, it's a 1 in 2. So it's a 50% chance that the 4th one's a daughter. Even if you already had 3, if you already had 3 daughters, the probability of the 4th one being a daughter is 1 out of 2. Now, if the question was, what's the probability of having 4 daughters? That's a 1 in 16 chance. But I just asked, what's the probability that the 4th child, only the 4th child is a girl, it's a 1 in 2.